In the previous section, we found the value of the 6 trigonometric functions of an acute angle theta when one of the functions is known, but not the angle itself. We'll now find the value of the trig functions when the angle is known. We can use geometry to find the exact values of 3 special angles, and those special angles are 45 degrees, 30 degrees, and 60 degrees. And we can find all these values with the following 2 right triangles. We have a 45-45-90 triangle and a 30-60-90 triangle. So in a 45-45-90 triangle, we have 2 of the angles. The 2 acute angles there are 45 degrees, and then there's our right angle, so that's our 45-45-90. And then in our 30-60-90, we've got our short side is opposite our smaller angle 30, and then we've got the longer side, the longer leg, opposite the larger angle 60 degrees. In the 45-45-90 triangle, the sides are always in this ratio. We know if these 2 angles, 45 and 45, are equal, we know their opposite sides must be equal. So let's say these are both 1. If you do Pythagorean theorem, you can see that that third side would have to be radical 2. 1 squared plus 1 squared equals c squared. If we solve for that c, we get 2 equals c squared, so c would equal radical 2. So in any 45-45-90 triangle, the sides are going to be in the ratio 1, 1, radical 2. So these are always going to be the same, and then the hypotenuse is going to be radical 2 times whatever these 2 legs are. In a 30-60-90 triangle, the ratio of the sides is the shortest side opposite the 30 would be, if it's 1, then the hypotenuse is double that, so it would be 2, and then the long leg opposite the 60 is going to be radical 3. So in any 30-60-90 triangle, the ratio of the sides will be 1, radical 3, 2. So if we have these 2 right triangles with the sides drawn, with the sides known, we can easily find the 6 trig values, the value of the 6 trig functions. So we remember our SOHCAHTOA to help us remember all those trig functions. So if I look at 45 degrees, so 45 degrees, I want my sine would be opposite over hypotenuse, so opposite either of the 45-degree angles here, it doesn't matter. Opposite would be 1, and the hypotenuse would be radical 2. So then our sine would be 1 over radical 2, and if we rationalize, multiply numerator and denominator by radical 2, then we'll get radical 2 over 2. So we like to write it in this form where it's rationalized. Then our cosine of 45 degrees, cosine is the adjacent side over the hypotenuse. So again, if you pick either angle, it's the same. So if adjacent to this 45-degree angle would be 1 over radical 2. So again, we've got that 1 over radical 2, which we know rationalizes again to that radical 2 over 2. So then we have our tangent of theta. So our tangent of 45 degrees is the opposite over the adjacent. So if I pick this 45-degree angle, opposite is 1, adjacent is 1, so that tangent value is just going to be 1. And then once we have the 3 basic trig functions, we can do the reciprocals to find the remaining. So the reciprocal of sine will give us cosecant. So if I do the reciprocal of 1 over radical 2, I'll get radical 2 over 1. And then secant is the reciprocal of cosine. So if I do the reciprocal of 1 over radical 2 again, I once again get radical 2. And then the reciprocal of tangent is cotangent. So the reciprocal of 1 will give me 1. Now, just to mention the radians, we know 45 degrees, if we wanted to convert that into radians, so remember we would multiply by our conversion factor of pi over 180. And then we can reduce, 45 goes into itself once, it goes into 184 times. So that's actually pi over 4. So if you want to add in your triangle here, we've got 45 degrees as pi over 4 radians. Okay, so now we've got our 30-degree angle and our 60-degree angle, so we can use our 30, 60, 90 triangle to find those trig values. So our sine of theta, so let's look at our 30 degrees first. So sine of theta is the opposite over the hypotenuse, so opposite 30 would be 1 and the hypotenuse would be 2. So our sine of 30 will be 1/2. And then we want cosine of 30. So cosine is the adjacent over the hypotenuse, so that would be radical 3 over 2. And then tangent is the opposite over the adjacent, so the opposite of 30 is 1, and the adjacent is radical 3. So I have 1 over radical 3. Whoops. 1 over radical 3, and I want to rationalize, so multiply by radical 3 over radical 3. So that gives me radical 3 over 3. And again, we've got the basic 3 here, so we can do the reciprocals to get the remaining 3. So the reciprocal of cosecant is sine, so if I do the reciprocal of sine, if I flip 1/2 over, then I get 2. So cosecant of 30 is 2. And then secant is the reciprocal of cosine, so if I do the reciprocal of radical 3 over 2, I'm going to get 2 over radical 3. But then I want to rationalize. So then I have 2 radical 3 over 3. And then finally, cotangent is the reciprocal of tangent. So if I do the reciprocal of 1 over radical 3, I'll get radical 3 over 1, so just radical 3. And then just to talk about the radians, so 30 degrees, if we convert that into radians, if we take 30 times our conversion of pi radians over 180 degrees, so the 30 divides into itself once, and it goes into 186 times, so that's going to give us pi over 6 radians. So we can add to our picture here, so we've got pi over 6 radians here. And then while we're at it, if we look at the 60 degrees, if we convert that into radians, so we'll have 60 times pi over 180, and 60 goes into itself once and into 183 times, so that gives us pi over 3 radians. And I'll let you guys go ahead and complete the rest of this chart here on your own.